Lessons 1 through 5, angles and constructions. So the first thing talking about is a line segment. So a segment has endpoints, whereas a lines that we've been graphing, if we graph it on the coordinate plane, like so, they do not have endpoints. They go on forever. We represent them with these little lines that show that they go on infinitely. But when we're talking about a segment, we give it endpoints. And this segment AB, we could label it with the endpoints A and B. Okay, so the next thing here is we're reviewing is something you may have learned in 7th grade math or something, different types, categories of angles. So pause the video and see if you can fill out as many of these as possible, what these names of angles are. And then turning back on the video, I'll put the answers here. So angles that are less than 90 degrees. Well, first let's start with angles that are 90 degrees. So this is a 90-degree angle, so it's a corner. And if we measured it, it's 90 degrees. And we call those right angles. And the way we label, name an angle, if we have 3 points like this, A, O, and B, we would put, this is a little angle symbol here. There's a couple different, you could also do an angle symbol without the little, so it can either be like that or like this. If you're writing it by hand, I suggest this one with the little arc through it, because this one can look a little bit like an L and be confusing. So we would call this angle AOB, and we put make sure to put the O in the middle because that's where the vertex is. And so that's another note we should write. The vertex of an angle is the part that's right in the center. That's the vertex. Okay, and angles that are less than 90 degrees, so are smaller than 90 degrees, are called acute angles. And I like to remember them because they're little and they're cute. They're small angles. Angles that are more than 90 degrees are called obtuse. We could name this angle. This one here does not have, well, I think I cut it off actually. You could also name an angle just by its vertex as long as that vertex is not shared by other angles. So because there's only one angle here, if we had another line that made 2 angles, we couldn't call it angle Q because we wouldn't know which angle Q we're talking about. But since there's only one angle, it's okay to call it angle Q. Angles here that make a straight angle, so a straight line is 180 degrees. We call those straight angles. Vertical angles are formed when 2 intersecting lines create opposite angles. So you make 2 lines and then the angles created that are opposite each other, in this case 2 and 4, vertical angles are equal. And another word we use for equal a lot in geometry is congruent. Same thing. And let's define congruent up here. Congruent means identical. And it has a fun symbol. It's an equal sign with a little squiggle on top of it, like that. So we could make a couple statements here. We could say angle 2 is congruent to angle 4. And likewise, angle 1 is congruent to angle 3. Okay, then we can actually measure angles. So in class, we measured angles using protractors. And we learned how to read a protractor. So let's look at the example of this angle here. And I'm actually going to use a different color. Let's try purple here. Okay, so we are measuring this angle right here. And you want to first recognize whether you're working with an acute angle or an obtuse angle. That's going to help you read the protractor. This tool is a protractor. So here we're looking at an obtuse angle, like this one. It is greater than 90 degrees. It opens up more than 90. So when we are, if we zoom in here to the, where the angle actually hits, we can see we have a couple of choices, right? It's either between 120 and 130, and that would be, I guess, this is 125 right here, so 126, 127 is one of our choices, if we're looking at these numbers down here. And then our other choice is it's between 50 and 60. So that would be 55 right here, so it'd be 53. So we have to figure out, well, which one are we talking about? And that's where knowing whether we're working with an obtuse angle or an acute angle would help. Because we see here the sides of the angle are such like this, that it's obtuse, it must be this bigger measurement. Now, if we were to look at the other angle that's formed from here to this line, so this angle, or this angle right here, that we would use the smaller number. That is 53 degrees here. Okay, and let's see. Now we're going to look here. Angles that add up to 90 degrees. So this is this little symbol means 90 degrees when you put a little corner on an angle. And so since that side is 90, we know this side must also be 90, because altogether it's a straight line. And straight angles are 180 degrees. So both sides must be 90 degrees. So then we know that these two angles, I'm gonna switch back to my blue. So we know that this angle and then this other angle add up together to 90 degrees because they are what's called adjacent. Adjacent angles share a side. So these two angles share and a vertex. They share a vertex and they share a side, so they're adjacent. And we know they add up to 90 degrees. And they have a name called complementary. Complementary angles add up to 90 degrees. And the way I remember that is complementary angles are always acute, right? Because they each individually are less than 90 degrees. And so they complement each other. One angle says to another, your acute angle. And then the other angle says back, no, your acute angle, or your acute angle too. And they give each other compliments. That's kind of a silly way to remember that. The other angles that add up to 180 degrees. So these two angles here add up to 180 degrees. And they, we call those kind of angles supplementary. And the way I remember that is it kind of looks like supplementary angles, kind of when they're adjacent, kind of look like someone doing the splits. Here's a face. You could make arms there, and these are the two legs, and there's their feet, and they're doing the splits. And another word for flexible is supple. So supplementary angles add up to 180. In class, we actually learned how to use a protractor. So if you're doing this from home, watch this video. And then we practice measuring these angles in this picture in class, and also in this one. And we got 40 degrees. So if you're at home and you have a protractor, or come to school and use the protractor, practice measuring. That was 40 and that was 50. And then we got 130 on this side and 50 on this side. And of course, they add up to 90 in the complementary angle and 180 in the supplementary. Okay, moving down. Now, supplementary and complementary angles don't have to be adjacent. They don't have to share a side to be complementary or to be supplementary. They can be in different places from each other. You could have one angle here and then another angle over here. And as long as they add up to 180, they're still supplementary. Then we did a little review of circles, and we reviewed that when you draw a line from the center of a circle out to any point on the circle, anywhere, it is called the R for radius. And all of the radii of any particular circle are equal. 2 radii together, we call that a diameter. And then we reviewed the formula for the circumference. So the circumference is the length around a circle. So if you were to take a string and measure all the way around a circle, then uncurl it and measure it with a ruler, that would be the circumference. So we could define that. It's the length around a circle. And it has a formula, 2 pi r. So circumference equals 2 pi r, or since a diameter is the same as 2 r's, you could write pi times diameter. The area, of course, is the area throughout the circle, and that has also a formula, area equals pi r squared. Okay, and we did this construction. We worked with compasses as well, so we did this in our book here to practice drawing circles with our compass. And then pi, as you may have learned before, is a long number, 3.1415, ... It keeps going on and on and on. And where pi comes from is pi is the ratio. If you look at the, let's see, we're going to take a little space here on the side. The formula for circumference is circumference equals pi times diameter, right? We wrote that down here. If we isolate pi by itself, so we divide both sides by d, by diameter, that cancels, and then we see that the circumference divided by the diameter is what pi equals. And this is very important, is the ancient Greeks discovered this. Every single circle, if you measure its circumference, and then you measure its diameter, the length across, and you divide the circumference by the diameter, you will always get this number, no matter how big or small the circle is. Any circle's circumference divided by its diameter is always 3.1415 ... And so we give that a very special symbol. We call that pi. Okay, so you're going to practice these here. We'll do one together. Find the circumference and area of a circle with a radius of 4. So r equals 4. We'll use our formulas. Circumference equals 2 times pi times r. So 2 times pi times 4, which equals 8 pi. So we're going to give our answer in terms of pi and the decimal approximation. So in our calculator, we could also do 8 times pi, and we would get a decimal, or round to the nearest hundredth, 25.13. Area equals pi r squared, that's our formula. So in this case, pi times 4 squared, which is 16 pi. Or the decimal equivalent, 50.27. So now we have one where we're given the diameter. Diameter equals 10. So when we use our formulas, we're going to have to remember we're talking about the diameter. We might have to divide that in half, for instance, to find the area. I'm going to let you do the math by yourself. I'll give you the answers. Circumference equals 10 pi. Area equals 25 pi. And then, of course, if you do the decimals, you get these. Okay, last one. What is the diameter of a circle with an area of 24 pi? So here we have to work backwards. So we're going to use the formula again. The area, which we know is always pi r squared, equals 24 pi. So we want to find what r is. Once we know the radius, we can use that to figure out the diameter. So we're going to divide we're going to get r by itself. Going to divide both sides by pi. Pi will cancel. We get r squared equals 24. The opposite of squaring a number is taking the square root, and we'll go over this in a future lesson a little bit more. But if we take the square root of both sides, we're going to get r equals the square root of 24. We can do that on our calculators. The square root of 25 is 5, exactly. So when we see this on our calculators, we won't be surprised that the square root of 24 is approximately 4.9. So then we can use that radius and double it to find the diameter. 4.9 plus 4.9 is 9.8 pi. Now you figure out the circle's circumference, knowing the radius and the diameter. Okay, and then the next page is a few definitions. We did this in our book. It's part of the homework assignment, those problems. The definition of perpendicular lines. So this is the symbol for perpendicular. And it makes sense because that symbol makes a little right angle, two right angles. So perpendicular lines are lines that intersect at 90-degree angles. And the definition of a bisector is if we draw an angle, here's an angle here, it's the line that divides the angle in half. So if we draw a line in the middle and it makes two congruent angles here that are adjacent to each other, then we call that middle line a bisector. So I'll just say line or segment that divides an angle in half. So that's the bisector. For these here, you'll need to watch these videos because it uses compasses, and I can't do that here in this setup. And then down here, you'll need to watch this video as well and bisect and do these constructions. You will need a compass. So if you're doing these at home, you'll need to, you can buy an inexpensive compass at a pharmacy, CVS, something like that, or stationery store, Office Depot, or Target. Any place that sells school supplies will probably have an inexpensive compass. Okay, that's it.